So without further ado, Tracey.
Thank you, Chris. And really nice to have everyone here. I'm excited about this panel. So, I'm with these HAQAST panels. We always sort of viewed them as sort of more of a loose federation of topics. So I'm not only talking about environmental consulting applications, but broadly everything that we have been doing and will be doing under HAQAST, but a lot of it aligns with private sector engagement. And this is just a schematic to kind of present my own perspective on how the tent has been getting bigger and bigger and bigger over the 4 generations of HAQAST. And of course, all of the types of organizations have always been welcome in HAQAST. This is not new that we're inviting, and we've had a lot of private sector companies be partners on projects and attend meetings and things like that. But I would say at a team level and at a NASA level, private sector engagement is really a huge priority across the agency and for HAQAST in particular. So I'm going to kind of talk about my work around environmental consulting and what I see as some exciting directions and kind of just a few thoughts. First, I'll say that, it was a real honor earlier this year, or I guess starting last year, to be invited by Susan Weirman, who chairs the Air and Waste Management Association Critical Review, to author the annual invited critical review, which the Air and Waste Management Association decided would be around the topic of satellite data to support air quality management. If you haven't been involved with the AWMA, they're really a largely industry group, a lot of consulting companies, a lot of legal organizations. And so it was an honor to work on this project with Jenny and Arlene and Gage Kerr at George Washington and Jingchu Mao at Alaska. And we presented it at the Air and Waste Management Association meeting in North Carolina. And I spoke about 2 weeks ago in the Great Lakes on the same topic. And then actually following this, I've been invited to give a webinar to an organization of regulated industries. So I think that as you start moving from one organization to another, and the relevance of satellite data is getting kind of wider and wider appreciation. Now, my favorite plot from this paper that we wrote was actually trying to evaluate which satellite products are kind of most mature, most ready for broader application. And, that's a hard question to answer, but one way to look at it is to say, well, where has the research been the most robust? And this is a time series of peer-reviewed citations with particulate matter, PM2.5, and aerosol optical depth at the top, followed by nitrogen dioxide, methane, and then with SO2, formaldehyde, and CO lower. So the fact that at these meetings, we hear a lot about NO2, we hear a lot about PM2.5, that is not surprising. Those really are 2 of the most mature products. So that was my favorite part of the paper. The favorite part of the paper from a lot of the stakeholders that we've been talking to has been a table that we made that really is trying to inventory all available data products. And we organize them broadly on geostationary, meaning that then they're seeing one area of the world through the day, like tempo, or low Earth orbiting, meaning they're seeing the whole Earth, but just once a day. So those are really different applications. And we also organize them if they're mainly used for gas phase species, or if they're mainly used for aerosol. And I think this is sort of at least the way that I think about these different data products. And this is just a screenshot of these of the table. But one of the things which goes on and on and on and on and on and on in the paper, which you're welcome to access. One of the things we also, though, found in thinking about satellite data applications, and this is something we found through ACAST and HAQAST for over 10 years, is that it's not a matter of just what data are out there, but how can we use them? And so one of the things that we've been doing over time, of course, is a lot of training. And we partner with the RSET program, and a lot of different groups come out with a lot of different tutorials. But this has been something that in my lab, we've been really leaning into for different reasons, sometimes to onboard undergraduates, other times to meet stakeholder demands. And these are just 3 of, I think, the kind of most popular, greatest hits of our tutorials page. One is a set of Python tutorials that take somebody from 0 coding experience at all the way up toward looking at NetCDF files and satellite data. Thank you. Another is for Google Earth Engine that Jennifer wrote a number of years ago, and another written by one of my students, Summer Aker, which is actually showing how to use Python to look at the WashU PM2.5 data in Google Colab. as we're sort of the tutorial that isn't yet up there, but is written by my colleague Pat Reddy with NASA funding, was developing Google Earth Engine toolboxes to identify exceptional event demonstrations. And that is a mature product that's been tested by a lot of stakeholders, and we will be uploading it maybe next week. But we've been doing a lot of business engagement beyond just HAQAST. And one is that I've been leading programs in energy at the University of Wisconsin, where we visited United Airlines. And this is my HAQAST colleague, Brad Pierce, when we visited a big energy company in Milwaukee. And we've also had NASA funding to think about satellite data for energy applications. And we've been having workshops around this theme of satellite data for energy since 2022. Including at NCAR, kind of focused on fire risk from power lines, and in Iowa on solar siting. And this has led to a new commercial impact hub funded by NASA that I'm working on with my colleague Daniel Friedland. So we're interested in satellite data, not just for air, but kind of for any energy issue, including generation support. Also, I mentioned in the intro that my own position has shifted a little bit, and I'm founding a new business engagement program in my home institution called the Nelson Institute. Business engagement the Badger way. We're all Badgers at Wisconsin. And just as an example, like we've been working with a lot of partners, but this is sort of just a screenshot. And the American Lung Association is one that I started working with through HAQAST, but then they funded us to do kind of follow-up consulting style work. Trek happens to be based in Madison, Wisconsin, and Alliant Energy is a big utility that we're working with, including they're probably one of the most excited about NASA data to support some of their issues. Speaking of the American Lung Association, last year they came out with a series of reports about the potential for satellite data applications. And one of the things that they really wanted to do was to see, can we calculate the kind of policy relevant, health relevant metrics that they use? And that is called a design value. And I just want to be clear, they asked for this. We are not trying to restructure the Clean Air Act. The American Lung Association, though, uses EPA calculated metrics at the county scale, where they take the highest monitor in the county and apply that value to the whole county. And so they asked, could we do something similar with satellite data, take the highest grid in the county and apply it to the whole county? So we did that. Actually, we found that was a little bit too sensitive to outliers. So we came up with a method of using the 90th percentile. And so this is sort of the example of what these design values or equivalents look like. But we've also been doing work to then figure out how many are true positives or true negatives, and we don't call them true, because what is truth? They're either aligned negative or aligned positive. And of course, we can only evaluate that where we have the monitors. And so what we've also done is trying to figure out where can we trust this alignment more or less. And we found that counties that have deserts or mountains or no cities tend to be the counties where we trust it a little bit less. And so this is sort of our green, yellow, red. And this is a paper that's led by my former intern and student Summer Aker, who's now a PhD student at the University of Illinois at Urbana-Champaign. We've also been doing a lot to think about how NO2 can be addressed at the surface level. And of course, the best practice is a machine learning. Oh, I wanted to say, I see Byung here. Thank you, Byung, for those comments on our work with the American Lung Association that just arrived in my inbox this morning. So it's a good thing I was prepping my talk this morning. And so we've done also a lot of work to try to think about how satellite NO2 columns can be relevant to surface levels. And we've done this both with computer models, like a paper that came out last year, doing simulated work with my colleague, Monica Harkey, but also thinking about what can we do with no model. And so one of my former undergraduates, Elliot Kim, who's now a PhD student at the University of Washington, evaluated a range of different statistical downscaling methods to move from column to surface. And you see here they are over 3 different cities, LA and Dallas, Fort Worth, and New York. And you get really quite different results depending on the ins and outs of the statistical method that you use. We also wanted to see, can we compare ground monitor and column data, not just at the annual average level, but also with a distribution. And this was a paper that Summer Aker led that was published in Atmospheric Chemistry and Physics, where we're looking at, do we capture a similar distribution of matches of highs and lows? And what we found that actually the biggest determinant of whether the patterns in the ground monitors match the patterns in the satellite data is road proximity. The further you get away from roads, the closer they align in their ranges. And I recognize these are different units, and so we used statistical comparisons that account for the different units. Just starting in our work is is that 1 minute? Okay. In my new proposal, we're working with California counties to evaluate the Blue Whales, Blue Skies program on vessel speed reduction. This was a project that was requested of our group by San Luis Obispo County, Santa Barbara County, and Ventura County. And we're really pleased to get NASA support to work with them, including the application of satellite data. And I think this really builds on some of the great work out of Georgia Tech that was looking at offshore emissions with satellite data and trends. They have already been doing a lot of emission inventory evaluation, so we get to sort of dovetail on the great work of the California Air Resources Board, the South Coast Air Quality Management District, and the counties that we're working with. We're also just starting work where we're comparing with NASA funding, and this is building on prior work with NRDC funding, to evaluate the AirMod model. And the AirMod model is, I believe, the most widely used model in the world, because every single facility that's ever permitted has to run AirMod, and it's mainly environmental consulting companies that do that running. And so there's been a big history of using satellite data to evaluate and improve photochemical grid models, like global models like Geochem, and regional models like CMAC. But I think this is the first time that it's being zoomed in to the level of evaluating these dispersion plume models. And actually the plume models typically just give surface concentration. So it's taken Jinran Wu, one of my PhD students who presented this in a poster last night, and Monica Harkey, one of my science colleagues, a long time to even figure out how can we calculate the vertical layers in a way that is comparable. So this is just starting, hot off the press, but we're excited to see where this goes. And I think just to end that, we're happy to work with different organizations, and including consulting companies and including states or others. And so, you know, I think we have a lot of these resources on our HAQAST website, but there's some work that my team is doing that kind of is HAQAST adjacent, and that's at the hollowaygroup.org. Thank you.
Thanks, Tracey. I think we're going to hold questions to the end as in the previous sessions, and then we'll have our speakers come back up, and one of the seats is not like the other. And then next, Nathan Pavlovic.
Perfect. All right, good morning, everyone. I'm Nathan Pavlovic. I'm lead geospatial data scientist at Sonoma Technology. My background's in geography and GIS. I've been doing that for 15 years with a focus on environmental science and the impacts of air pollution on health and the environment. And for the last 10 years, I've been working at Sonoma Technology. And so I think I bring sort of an interesting perspective, entering a consulting company, having come from that sort of geospatial Earth observation background and trying to figure out, okay, how can we use this? Can we use it on this project? Can we use it on that project? And so today I want to talk a little bit about my experiences across a range of different areas that we work in using satellite remote sensing in this consulting setting. First, though, a little bit more about Sonoma Technology. So we're over 40 years old. We've been providing innovative science and technology solutions to air quality for clients around the world. We are based in Sonoma County, California, hence the name, but we have staff all over the country, including myself in Washington, D.C. And we provide services across a range of business areas, including air quality, meteorology, transportation, expertise in low-cost sensors, emissions and emissions modeling, fire and fuels modeling, forecasting, and other business areas as well. And so we really bring the sort of science perspective to a range of clients. So I want to talk about three sort of separate but maybe not so separate business areas that we work in, where we use Earth observations in various capacities. So those three areas are research applications, by which I mean work that really answers on work that focuses on answering fundamental or applied science research questions about atmospheric processes, air pollution, emissions, and health effects of the exposure to air pollution. Operational applications, which is focusing on supporting decision-making by companies governments and the public, and then regulatory applications, which seeks to provide evidence related to regulatory decision-making. And there's some overlap here in terms of who we're working with, but there's also a lot of overlap in terms of the methods that we're thinking about using to support these different application areas. And I've outlined a range of them. This is far from, complete, but it's covers a lot of the areas that we work with: emissions estimation, statistical and physical modeling, satellite remote sensing, which at least should be a part of everything that I talk about here today, geostatistical analysis, data fusion and machine learning, which is I think almost every presentation has touched on that so far this meeting. So I think it's really interesting to see everybody sort of moving in that direction, and I could talk more about that. And then, of course, data visualization, interpretation, and distribution. And so I want to share just a couple of examples of projects in each of these research applications, and then think about what does this mean for the perspective of working with consulting or within the consulting environment, thinking about applying NASA Earth observations to the challenges in each of these. So I'll start with the research application areas, and that's what I'm used to talking to at meetings like this. So maybe I'll talk a little bit more about it than the other areas, but I'll try and keep it pretty even. So we do a range of and support a range of work across health exposure assessment, emissions estimation, high resolution estimation of air pollution concentrations. And so this project is, or actually is a series of projects working with collaborators at USC to develop high resolution air quality exposure maps for California for nitrogen dioxide and PM2.5. And so just a brief overview of the processes there on the right for PM2.5, and then, sorry, on the left, PM2.5, and then on the right, a model that's currently on archive and in review, so should be out soon in a journal. But using deep learning here really to pull together all the sources of information that we have available to explain or to predict what the pollution concentrations were at any given location. We also do, and my background actually is in wildfire smoke and wildfire detection with satellite remote sensing. That's how I got into the field originally. And so we've done some work here, first detecting wildfires. So we were interested in understanding the sub-daily fire growth for wildfires in California. And so we developed a method using MODIS and VIIRS to map out that progression on an observation by observation basis. And then compared that to agency reports and found excellent agreement, especially for VIIRS, with the enhanced resolution. That data then can feed into emissions modeling pathways of a variety of types. And I think the sub-daily perspective is especially important for fires because we think a lot about fire emissions. They're very uncertain, and there's uncertainties not just with the emissions, but also the plume injection height and others that folks have talked about. One of those sources of uncertainty is when is the fire burning? And most emissions models that folks use just sort of assume, yeah, okay, it's hot in the afternoon, so we're going to have more fire. And maybe on aggregate, that's correct, but we're seeing increasingly that that's not true for most major fires, at least in California. Actually, you get these nighttime offshore winds that really drive growth, like we saw in the LA fires earlier this year, some of the fires in Sonoma and Napa County in the late 2010s and others. And so that's actually really important because you got offshore flow at nighttime, you've got onshore flow during the day. And so if you've got the timing wrong, you're sending the smoke in the wrong direction. And that really makes a difference in your pollutant concentrations and where the smoke ends up. And so we've done some work over years with the U.S. Forest Service to develop this pathway called Blue Sky and Smart Fire that really go from what do we know about where the fire was burning all the way through each of the steps to emissions and then eventually downwind concentrations of air pollutants. And then, of course, one of the main reasons that we're interested in where does the smoke go or where is air pollution highest is because we want to understand how this impacts human health. And so we work with researchers across the country to understand those health effects and develop understandings of the associations between air pollution exposures and the health effects of that exposure. And so we've done work on, for example, adverse birth outcomes related to heat stress and wildfire smoke. Found that those are related, and also that climate vulnerable neighborhoods have a higher or stronger association with those factors than other neighborhoods. And then we've also worked on pregnancy outcomes and preterm birth, and found that preterm birth is more likely when you have an increase in wildfire smoke exposure, as some examples. There are, so that covers some of the areas in very little depth that we've done research on related to air pollution using satellite data and the health effects. So I'll talk a little bit now about regulatory applications. The area that I'll touch on, and this is just one of a number, is exceptional events. So these are cases where an exceedance was caused by typically a wildfire. It can be stratospheric intrusion or other causes as well. EPA has a process that you can exclude certain data if it was impacted by this exceptional event from regulatory decision making. And so that's important because you want to hold locations accountable for the things that that local sources cause. But if you can't control the source, what good is it to impose a restriction on them if they can't do anything about it? And so we've done this work supporting state and local agencies in developing exceptional event demonstrations. And in doing that, we found that we were doing similar things over and over again, and said, hey, can't we scale this up? And so we took that expertise, we took the range of data sets that we typically use in looking at, hey, was this an exceptional event? And we developed a screening methodology that takes the best of each of those data sources, puts it into the screening methodology that's shown here on the left, and then used it to determine where across the US was there a probable exceptional event. Now, of course, this isn't to the level that's required for a true exceptional event, but it gives agencies a chance to say, hey, here's a day that I should take a closer look at. And we've been sharing this out with agencies across the country. And they've been saying, hey, this lines up with what I understand. Hey, I need to take a look at that day more closely. And we're really excited about that. In review currently, hopefully be out soon. The last area that I'll touch on is operational applications. So this is really providing real-time information for companies, for agencies, and for the public to help improve decision-making about regulatory processes, about personal decisions, about where do I send an employee, that sort of thing. And so we supported the EPA Air Now program for a long time. There's a mobile app that we've developed that you could download out on your phone that provides air quality information in real time. We also developed an application that looks at Kansas Flint Hill burning and helps determine when's the best time to burn, which is a practice that's really necessary for the agriculture there. When's the best time to burn to minimize impacts on downwind populations? And so that tool runs on a regular basis. We help state and locals do forecasting on a regular basis, and that pulls in data, including satellite imagery. And then we've also developed a data fusion product called ExactAQ that companies can use to support decision-making around current air quality at hyperlocal resolution. So just to conclude then, we've got these range of applications, and satellite data is critical for many of these. And so that's really exciting. And we're constantly looking for new ways. I'm constantly looking for new ways to pull in satellite data because I think it's so exciting and advancing so quickly. The important consideration is that outputs need to be tailored to the objective of the project or the objective really of the end user. And the processing of that is really important. That includes the formats, the storage, the compute, and the output result, like how is that delivered? And so thinking about these diverse applications and sectors, everybody has different motivations, objectives, and requirements. And so just as an example, in the high resolution data product that we provided, we said, hey, we went to our forecasting group and said, hey, can you use this? And it's like, well, you're doing a really good job of reducing your RMSE. But what we really want to know is the probability of an exceedance. We don't care about the absolute concentration. We just want to know, do we need to spare the air day tomorrow or not? And that really matters. I mean, that packaging makes a big difference. And so I think as we think about how do we engage consulting and private sector more within HAQAST, I think the HAQAST model is actually really exciting because I think you need to start with the end user and what is their objective before you build the product, because that output format and really the statistics that you use to get there needs to critically be driven by what is the need of the end user. And so I'm really excited about that new direction. I think it's really interesting. I think there's going to be probably some challenges in figuring out how do we get those pieces to fit together, and excited to see where it goes. So thank you.
Thanks, Nathan. We've had a wonderful, great first couple talks, and looking forward to continuing that with Chris. Please feel free to come up.
All right.
all set.
Great. Thanks for the opportunity. I'm going to talk about a data product that we made from nighttime VIIRS data. It's called VIIRS Nightfire. And this is sort of a brief tour, but if you want to have a fuller tour or talk to me by email, I'm happy to do that. All right, so this product is made from VIIRS, the Visible Infrared Imaging Radiometer Suite that is flown by NASA and NOAA. And it has something that it does very interesting at night. It collects 2 near-infrared channels and 2 shortwave infrared channels that are designed for daytime imaging. And it continues to collect that data at night. And these spectral bands are found on a lot of Earth observation sensors, but normally they're not collected at night. And if you ask the operators, they would say, well, there's nothing to see. Well, there's almost nothing to see. There's a little bit there, and it's coming from infrared emitters. And so when you look at these 4 spectral channels that are at the top of this chart, though you're seeing primarily the noise floor of the sensor, but it's punctuated by high radiances coming from infrared emitters of various types that are present at the Earth's surface and even on the ocean surface. So our algorithm specifically uses all of these nighttime bands, but we get a tremendous amount of value from these daytime channels because they have much lower detection limits for most types of hot objects than the midwave infrared. And we can take all of that radiance and count it into our analysis. We don't have to split out a background. We've got 4 spectral bands where we don't have to be concerned about the background. All that radiance is coming from the infrared emitter. And what we do is Planck curve analysis. And so our standard product fits we run detectors, and then we do Planck curve fitting with the observed radiances in those bands. And we fit for a background at a low temperature and covers a very large part of the pixel, and then a high temperature infrared emitter. And then we use physical laws. And so once we have the Planck curve, we can go on and apply physical laws to calculate the temperature with the Wien's displacement law. We calculate the source area by manipulating the emissivity term in Planck's law, along with our knowledge of the pixel footprint size. And we calculate radiant heat in megawatts with the Stefan-Boltzmann's law. And note that the radiant heat megawatts, that's the same units as the standard VIIRS fire product reports fire radiative power, same units. But that standard product, fire radiative power, assumes the temperature is 1000 K. And we don't make that assumption. We actually calculate the temperature. All right. Now, we've got this data going back to 2012, nightly, global. And one of the things we do is distill it all down to a set of industrial or fixed location infrared emitters. And so we tease apart the fires, and we know that there's users that are specifically interested in fires. But up until now, our primary focus has been on industrial emitters. And we have a web map service called the Global Infrared Emitter Explorer. And here's the opening page. And you can see this is focused on North America. And all those marks that are colored are known infrared emitters that we track and develop temporal profiles. And we do our best to split them up and label them. And we're currently tracking about 20,000 infrared emitters of various types around the world, with data coming in every night. And we update the temporal profiles once a week. Now here's zooming into St. Louis. And so there's a set of industrial emitters that we've never attached labels to on the west side. Just across the river in Granite City, there's US Steel with several different emitters present. North of US Steel, there's a couple of refineries, and then there's a landfill. And so just about any place in the world you go and look, if there's an urban area, there's usually some industrial sites that have detection. Here's, if you keep on zooming in, you begin to see these individual emitter sites, and the place mark is at the centroid of the feature. And also the bubble vectors, we call them bubble vectors. These are the bounding vectors around each infrared emitter that we use to assign the incoming data to its known emitter source. And on the right-hand side, you see these little chips. There's one that's colorized with a red core right here. So this is the super resolution image. We do our identification of potential infrared emitters with 15 arc-second grids. But when we go in and split up and define the bounding vectors for individual emitters, we go through this analysis where we're not using the 15 arc-second grid cells, we're using the actual latitudes and longitudes for the detection pixels, because that's embedded in the data, the real latitude and longitudes for the pixel centers. And so when we pile those up together, we start to see shapes. And this one, you can see it's elongated. And so we ended up dividing that into 4 individual emitters. And later on, we test to see, are they different from each other in terms of the temporal profiles? Now, when there's a single emitter, you see a tilted square, which is actually the projected outline of a edge of pixel VIIRS, edge of scan VIIRS pixel footprint. And so we use these super resolution images for every emitter in order to understand what's going on. Is it a single feature or is it multiple features? Can we split them apart? Okay, and here's the temporal profile for the primary feature across the river in Granite City. The top panel is the shortwave infrared radiance. The middle one is temperature, and then the lower one is the radiant heat in megawatts. And so this site started out at a very distinct activity level, and then there was a long gap from, it started at the end of 2015, and it came back in the middle of 2018. So there's a more than a 2-year gap where there was very little activity at that site. And then it came roaring back about the middle of 2018. And then it literally went away. So here in towards the end of 2023, you can see the radiance, the signal drops, and there's an actual gap. And then it comes back. There's another gap, and then it comes back, but it's at a lower radiance level, a lower temperature. And so I believe that their industrial process changed. And so I don't know what it was, but these are telltale signs that their industrial process changed, and they had some periods where they were absolutely down. They were not doing any work that was detectable by satellite. Okay, so we make this data product from all 3 VIIRS instruments. It's 150 gigabytes per night per satellite. and we process it in near real time. There are two versions of VNF, version 3 and version 4. Version 3 assumes that there's a single infrared emitter. Version 4 tests the detections to see if you can split out a high temperature and a low temperature emitter. And for biomass burning, that low temperature emitter is pyrolysis and preheating, which is important for modeling smoke and trace gas emissions. We have a defined process to take all this incoming data and filter it down to a set of persistent infrared emitters, which we catalog, and we produce temporal profiles for each. These temporal profiles can be interpreted to identify activity changes over time. And this is a licensed product. We have several paid commercial subscribers, but it's free for academics. Okay, that's it. Thank you.
Thank you very much. Great presentations. And then to our next speaker, Cynthia Randles with Scepter Air Incorporated.
Thanks. Nope. Hi. Sorry, I don't have a ton of slides. I thought it was like more of a panel discussion, but that's okay. My name's Cynthia Randles. I'm an atmospheric scientist. I'm consulting for Scepter Air. Scepter is building a geospatial data platform that is sensor agnostic. So it can take in multiple types of sensors and be configured in any way to answer a question of a client. So one of the premises we have at Scepter is that you need to understand the atmosphere from multiple perspectives for a given problem. So no single type of sensor is completely adequate for any given problem. So sampling the column from multiple perspectives can give you a fuller picture of the problem you're trying to address. So that can include ground sensors, drones, aircraft, stratospheric balloons, all the way up to satellites. And so each of these types of sensors fused together can give you a fuller picture of what you're trying to understand. And so we look at this as sort of like having a gap sometimes in your atmospheric intelligence. And so the way to address that is to combine multiple types of sensors. And sometimes, you can pull those from public sites, from NASA satellites, from EPA stations. But sometimes, depending on your application, you may need something additional. And Scepter can also help provide that, whether it be ground sensor systems, working with partners, or we also have our own VIIRS sensor and VIIRS sensor that we can fly either on aircraft or on stratospheric balloons to give you sort of like a stronger spatial resolution. So we've mostly worked in the past in the methane world, and I've spent the past 8 years working on methane and doing this for industry. And so here are two examples of plumes of methane at oil and gas sites. The left is from Tropomi, which this is not a product that's available from ESA or really anything. So we do the in-house processing to be able to provide, and the remote sensing to be able to provide products like this. And that's something else we can do within our platform, depending on the application. So this is a methane plume from Tropomi, and Tropomi has a very coarse pixel resolution, like 5 by 7 kilometers, and it can detect really big plumes, like on the order of 10,000 kilograms methane an hour. On the right, I'm showing from our own sensor flown on a stratospheric balloon, which we were the first to ever fly a VIIRS sensor in the stratosphere on a balloon. And this is over the Permian Basin, and we were getting down to like 20 kilograms per hour of methane, which is quite low. So it's just showing that you can, for any given problem you want to answer, you might need a multitude of sensors, right? And you might need to gap fill by adding additional sensors depending on the problem at hand. I'll agree with my previous colleagues who talked about also doing this sort of data fusion approach. But one thing I'll add is for certain customers, an additional dimension is time. So doing things in a very timely manner is really important for a lot of clients, especially in the oil and gas industry, for example. You know, if you find something 3 months from now and you tell them, oh, I saw this in the satellite, that's not sufficient. You can't actually act on that information. You need information as soon as possible. And part of getting information as soon as possible is not trying to be, say, overly scientific about it, right? It doesn't matter to the, second decimal point what the emission was. It's like, was there an emission? Is this something I can send a guy out and go fix? And so at Scepter, we're trying to build a system that can provide that sort of actionable data to our clients, because in a lot of instances, what they're really interested in is mitigation, not sort of the quantification necessarily of what they're seeing in terms of pollution. Because at the end of the day, they just don't want to admit it. That's all I had, so I guess we can just go to the panel.
Wonderful. If we could just ask our panelists to head up to your chairs. They're at the front. I personally find this works great when everyone sort of chimes in. Like, don't feel like, oh, they're on the chairs. I can't, I can't share my perspectives.
I have a microphone, so if you have any questions, I'll bring it to you.
Hi, thank you guys. This is really interesting. I was really curious, even with the last speaker, but maybe anyone else can say, like combining multiple things together at different spatial and temporal resolutions. And like, especially when you're working quickly and you're trying to say, hey, I need something real now. How do you guys go about combining like different temporal, spatial, like sometimes it's daily, sometimes it's minutes, sometimes it's I can get down to the ground. How do you go about combining all of those things together?
So I think it's application dependent and sort of what you're trying to achieve. So for example, for ExxonMobil, we were ingesting thousands of their own ground sensors that they had for methane detection around their oil field, and then having the satellite data. So it was, the ground sensor data being point data doesn't give you like sort of contextual information about what's going on in the broader area necessarily. So it was using satellite data when available to contextualize what the ground sensors were saying and sort of to truth them in a sense, so that you could know if, was that something that happened at my site or did it come from the guy next door to me? So it is a little qualitative in a sense, but that's okay because that's what they need. And that's, I guess, sort of one of my points is that in this sort of environment, in a consulting environment, you don't always need that really precise scientific way of doing, say, data fusion. I've had this conversation with folks who are like, you're not doing data fusion because you don't have an inverse model and blah, blah, blah. And it's like, well, no, that's true. We're not doing it to that, degree of, scientific rigor, but that's not what our customers need. They need to know, okay, was that my plume? Like, do I need to send a guy out in a truck to fix that thing or not? And so we can get sufficient information to give them a good answer to that question. And that's kind of how we approach the problem.
Yeah, and I'll say, I mean, I think something I heard across this panel is the application dependence. Like you really need to start with the user and work backwards from there. And I think one of the reasons we found Google Earth Engine to be such a great platform, for example, is it can integrate a lot of different data at different scales together in one platform. If you don't use something like that, then really it kind of bumps it up to a higher level of analysis because you have to pull it all into your own Python or whatever system to be doing the analysis there. And I guess one thing that I found is that the way that scientists have traditionally been analyzing data has been very good for a lot of things, but it hasn't been good for everything. And I think that this is sort of an example where, this, like when we were analyzing the county level data for the American Lung Association, like they wanted it analyzed the way that they had been analyzing data from monitors for 20 years. But analyzing like grid to county, like this is not something that, scientists have been analyzing grid scale data forever, but not in this like specific county level metric way. And so it's not like it was not that hard to do once we started doing it, but it was just an idea that I would not have thought about if it hadn't been suggested by our partners.
Yeah, I think it's a really good question, and I think there's two sort of cases where I see this. I think half the time when I run into a data fusion where I've got different spatiotemporal resolutions, we can actually take advantage of the strengths and weaknesses of each and produce something that's better than the sum of the parts. And a case of that is with the wildfire detection work that I talked about. We've, beyond the paper that I cited there, we've taken the GOES geostationary satellite data and combined it with the polar orbiting data from VIIRS and MODIS. And what you have there is a much larger footprint from GOES, but you have high temporal resolution. We use it at hourly, but you could even go below that if you wanted to. And you can combine that with a very high spatial resolution of the polar orbiting data to get a sense of, well, we have an accurate sense of what the footprint is at these timestamps, and we can fill in the gaps temporally to know exactly when the fire was active. And so I think there's cases like that where you can really use smart data fusion techniques to combine them. The other is sometimes they just don't work together, and you have to just acknowledge that. And a case of that is, and that doesn't mean you can't use both types of data, but a case of that is if you want to look at hourly data, using filter measurements that are 24-hour from the regulatory network is just, you can't really take that down to hourly, but you can use it to validate. You can average up an hourly product to a day and say, okay, well, we've got the filter data to compare to, and that gives you a sense of how you're doing. But from a fusion perspective, I haven't seen someone, use that data in a way that really, does that sort of same, the whole is greater than the sum of the parts type of application.
We got a lot of mics.
Thanks. So I have a question that I would love to hear from each of the panelists about, and it has to do with this sort of cross-sector partnership. And so I was struck in, Chris, your talk that you mentioned, this is licensed, it's free for academics, but, and so I think one question is sort of what are challenges, but also opportunities about these kind of partnerships? And I know that Cynthia has been at kind of a large, she mentioned a multinational corporation, but also now I assume it's smaller consulting company, and also at a government lab and international organization. And so I feel like you've worked in these different environments. And, Tracey, you're starting this business engagement. And so I feel like there are different challenges that come up as we sort of start to bridge into that sphere. And Nathan, you've mentioned working, across different groups. And so I think one of the things that strikes me is that sometimes if I talk to academic colleagues, there's this sort of impression that, well, we're doing all this work in open access and making it all available, and then these other groups get to profit from it, and like they have all this private data, but we don't have access to it. And so anyway, sorry, this is a big, broad topic, but I would just love to kind of hear what people's thoughts are.
Yeah, sure. Well, for us, the commercial subscribers are very important for our annual budget because we have to cover our staff salaries and all of our activities. The university gives us access to the internet, but then we're on our own. And so we get, I guess, around 20% of our annual budget from commercial subscribers. We usually don't get much back from them. We get their money, but we don't really know what they do with the data, what type of other types of data they merge with it. Our data is very amenable to all that because it's geolocated. And the commercial subscribers find a lot of value that we do all the upfront work to collect the data, analyze it, and make the temporal profiles and keep those up to date. And currently from 3 satellites. And so we know that they get sufficient value out of it that they renew their subscriptions. And so we have a vastly larger number of free academic license holders. And when they write papers, their license says that they'll cite us. And so that's a more intangible benefit, but it's definitely a positive.
So I'll say this from my previous corporate life in the oil and gas industry is most individual corporations are extremely careful with their data, right? Data privacy is something they will not violate. And that I don't see changing ever. Now, one way you can work with industry, though, is through industrial consortiums. So, for example, the EDF has been very good at this, taking data over Texas. And by working with a large number of individual corporations, you can anonymize data so that any individual company doesn't feel singled out, that, you know, they're getting their sort of privacy violated by, you know, participating with academia. So I think that's kind of maybe the best way to approach working with industry and getting data about industry, because that enables them to feel like they're getting something out of it and being able to sort of raise all boats. And this is specific to like environmental sort of problems, I'd say. But as individual companies, they're going to be very reluctant to kind of do that kind of thing. So that's kind of, if that answers your question.
It just sounds like there's a parallel to health data, right? Where there's all kinds of restrictions, but
Yeah.
maybe there's something with environmental data that.
Yeah, exactly. So like the more you aggregate it, the more you anonymize it, it helps them because then they can benchmark themselves, right? But at the same time, they're not like outing themselves in a way that is not good for them as a corporation.
Oh, well, I love your question, Arlene, because this is something that I've been thinking about for a long time, really inspired a lot by the lessons that I've learned through the HAQAST community. And, you know, I think that to me, it's helpful to sort of zoom out and think about how do scientists usually do their work. And the typical way that scientists in like a lab or a university environment work is that they're sitting in their office and then they try to think of an idea that nobody's done before. Okay. And then they write a proposal to do that idea to an organization whose only job is to hand out money. And then they get the money and then they hire a grad student. And then maybe like 3 or 4 years later, they deliver the results of that work. And, you know, that system has worked fantastic for the US scientific enterprise. I mean, there's nothing wrong with that system. But I think that it's naive to think that that's how everybody works, because actually most businesses, most air quality management organizations do not want to wait 4 years for an answer. They do not have a mission to just hand out money to the topics that the professor thought was interesting sitting in their office. And so actually you have to flip it on its head. First, you have to start building connections with different organizations, listening a lot. Like you have to listen, and ask questions and be interested and not assume that they're going to give you their data and not assume that they're going to want something published in the peer review literature, and to really understand, like, why are you interested in this and what are you currently using? And through those kind of conversations, you may decide that, like, okay, this is not a good fit for me. And over the years, for example, I've been contacted by companies who wanted us to model like, you know, explosions or industrial releases, which is just, that's a more of a environmental consulting thing to do. Like, I don't want to step into the middle of some like super litigious situation. Another thing would be something like that they want done in 2 weeks. Like, sorry, like if we're teaching classes or doing other things. So I think that like this idea, like just because you're listening and having these conversations, like you may very well find that it's not a good fit, and or for a lot of different reasons. But you may also find that it is exactly a great fit. Like they want exactly what you would do anyway. And so in those situations, like setting it up like a research project, and I'd say that that's a very HAQAST-y way to approach things, that the projects that we're doing in HAQAST tend to be projects that the researchers are interested in doing and are willing to do. But I would say that there's sort of a middle ground where it's something that may not be your first choice of things to do, but or maybe they are trying to do it on a timeline that is a little hard to manage, but that you're willing to do it and you could do it. And I think that this is where it comes, and maybe even you're very happy to do it because it provides an extra source of funding. And I think that this sort of middle ground where there's the question of, I could do it, I'm willing to do it, but like, ugh, I'm really busy, you know? Then there's the question, I mean, that's something that any business, like, what is the reason why somebody works extra overtime? It's to make more money, you know? And I think this idea of like the money, like recognizing that if you can commoditize some portion of your work that you're interested in doing, it can stabilize your budget. It can open you up to partnerships that maybe first they want you to do what they want you to do, but then down the road you can get a dialogue going and maybe that they'll be interested in doing what you want to do and learning from each other. So I think one of the ways that we've been kind of building the business engagement program at Wisconsin that I've been approaching has been to sort of view it as kind of a 360 perspective. Like we're not trying to convince them to replace the NSF, but we're trying to say, well, we can work with you in this way or this way or this way. Like we can bring students and faculty down to your offices to understand what you're doing, which is great for the students because they get to like learn and meet professionals. We can bring people into the classroom to like talk. And actually my air quality class this year is being taught by a consultant from TRC from the first time. So actually the students are getting to hear from like real world professionals working in this area. But also sometimes we find a research project that's a traditional research project. Other times it's more of a contract. So I think that, at least to me, it's been really helpful to have multiple ways of engagement so that, which is exactly what we're doing, to be honest, with HAQAST, except with HAQAST, NASA is funding us. So we don't have to be expecting funding from any of the attendees here. The NSF has set up something, and I know one of your colleagues here, Adams, is leading one called an IUCRC, where companies have to pay $80,000 to be part of a consortium. But I think it's a big jump to go from 0 to 80,000. I mean, that is a big jump. And I think having different ways that we can work together at lower cost to build relationships, we found that to be really helpful.
I don't know that I have too much to add to that, but I'll just come back to my conclusion of my presentation, which I think is it's really starting with the motivations, objectives, and requirements of the end user, and the contracting and private business motivations, ways of acting, and requirements are quite a bit different than I think how many academic folks are used to operating, and so I think there is a different way of operating there that starts with that dialogue and understanding of, well, what is this person's incentives and interests and needs, or organization, I should say, rather than person.
I'm Byung Kim at Georgia EPD. It's a state air agency, and one thing that I want to share my perspective about kind of building a relationship or possibly expanding the use of those sort of commercial version of the data is that as a state agency, on and often that what we encounter as a challenge is that we don't know what product we end up really getting at unless we actually try it out. And based on my limited experience in the past, that some of the commercial products, it's just hard to imagine whether it's going to be really useful. And I miserably failed to sell my idea of this can be good to my upper management because I cannot demonstrate it. But that being said, it'll be really great, at least some of the vendors can offer sort of trial version of it so that state at least can taste what it look like. Otherwise, it's almost like a blind shot that we have to say, this must be good, but until otherwise we actually have a funding to buy your product to prove it's good. And I don't know whether that will really work out. And also the other aspect of it is, like a state of Georgia, we have a Open Record Act that we have to turn in all the record that we have. And that gets a little interesting for any product that tied to the copyright and things like that in some cases. So I'm just saying that, like, I was curious about the VNF product, and it says commercial. I know it has a bunch of meanings depending on who you ask. And on and off, even some of the Python like a service that we've been using, it turned out they changed the definition of the commercial in the middle of I guess 5 years ago. And now the state entity become commercial, and we never thought it will be commercial. So we had to uninstall every single one on our system and switch back to the real free version because it didn't work out. I mean, it just so that I'm just sharing again my perspective that even including the Google Earth engine, we cannot convince our upper management. And the basically question is, can you do it with the Google Earth without Google Engine? And it's, yeah, then no, that's not going to work out. So it's just one of the things that I would like to ask you to consider, at least to give a like free trial version at the beginning. So at least we can see what we can get out of it and whether we can estimate kind of return of investment. So
yeah, I understand. And we do provide free samples of temporal profiles or the nightly data products. And it is, there's a gray zone between a commercial entity like Exxon versus a state agency versus a federal research lab. We're always, every year we really have to scramble to get the money to pay for our salaries. And so if a organization is, even if they're nonprofit, if they are well funded, then it's not inappropriate for them to give us a little bit so that we can keep this thing going. And so we occasionally face those hard questions like you've just posed. And we just do the best we can. We offer free data samples and try to work to determine, can this organization reasonably pay $15,000 a year? It's for us, it makes a big difference. If it's chump change in terms of their budget, then we should ask them.
Yeah, I think it's a really interesting question, and I've been working in the satellite industry for a little while, and on the commercial side, and it's been interesting to see because a lot of us are used to using the nice data that NASA provides and the nice data products, but if you added up the amount of money that goes into the development of those products, it'd be astronomical, right? And once you're starting to move to buying private data products, I think you just have to realize that there's people that have to produce it, there's computers that have to process it, and nothing is really free. And I'm afraid we're moving into an era where we may be confronted by this more and more. And I think as like a community, we're going to have to figure out creative ways of dealing with that potentially. Because in reality, no data is free, especially satellite data. It's probably about the most expensive data you can get. So, but I think, maybe that's a role HAQAST can try to play into is like, how can we bridge this gap between sort of free data products and maybe more expensive data products? How can we pool resources to access those sorts of things? Because, at the end of the day, data does cost money. Right?
Yeah, I mean, I think these are great comments. And I a few kind of like things that we've been thinking over the years is that there is this feeling that, like, if it's free, like it's sort of the narrative that HAQAST has been advancing over the years. It's like, here's all this free data and we'll show you how to use it totally for free. But even that is not for free because everybody who's in this room is spending your time or learning, going to workshops or whatever. I mean, there's the money, but that's at least kind of like an in-kind contribution. You're not having to like ask a supervisor for a check. But as we start thinking about like broadening the use, we have a lot of users who's like, well, we'd love to use it, except we just need higher resolution, more frequent, more this, which is great, but nobody, like, it's very hard to justify to NASA to invest in more instruments if people aren't using what's available. So I just want to, first of all, thank everybody from the stakeholder community and the research community who's here, because if you're not here using and engaging with what's already available, it is almost impossible for NASA to justify the next generation, the next generation, the next generation. And within the air quality community, I think it's also worth noting that like there's a lot of environmental consulting companies, and these companies typically do things that tend to be a little bit more technical or a lot more technical and like at high level than and that may include like writing an exceptional event demonstration, which has a lot of satellite data in it, or it may include running the AirMod model, which relative to models is a very simple model to run, but actually it has its own quirks and it takes a long time to figure out how to do it smoothly. So, you know, I think this idea that could environmental consulting companies start to play a bigger role in being the bridge between this kind of hard to use satellite data, even the free satellite data, and supporting users' needs? Like, I think that it's an untapped opportunity. And I'll just say, when I was at the ACE meeting for the Air and Waste Management Association in June, they have these beautiful booths, you know, and all the booths have like candy and pens and things like that. And so I felt if I was going to get my swag, I needed to like chit chat with people. And so I just said, do you use satellite data? Do you use satellite data? Do you use satellite data? No, 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 no. I met a lot of great people, got a lot of great cards, but nobody uses that, even the companies that are providing multi-data platform solutions. And so I just think it's an untapped opportunity, and it would be great if, you know, we could do it for everybody's benefit. And I also want to say on Google Earth Engine, maybe Pat can say a few words on that, because it is really complicated how Google Earth Engine sort of views commercial versus non-commercial. Yeah, maybe, why don't you go, Nathan, and then Pat can say a few words.
Great. I'll try and be pretty quick. I think it's an interesting question. It's kind of a business question, how somebody, you know, how an organization chooses to market and whether you're the target audience or not, right? But I think the reverse question is also really interesting for HAQAST. How are businesses going to receive free help to use satellite data, and how will that move forward in the future? And I think it'll be interesting. There's a question: is usage a barrier because there's like a startup cost that something like HAQAST can get over, or is it a sustained use cost where the juice isn't worth the squeeze over time? And that's going to depend on the use application. I mentioned in my presentation that, you know, I'm always like, can we use satellite data for this or that? A lot of the times the answer is no, because it's too much work, and I can't say, yes, this is definitely going to improve the result for our specific objective.
Mm-hmm.
And so I think it'll be interesting, an important thought moving forward, how that plays out on a case-by-case basis.
I'm talking about Google or some of Google.
So Google Earth Engine is free for research and government work, unless you're doing something that's a regular product. So if you're doing annual exceptional event reports, they would consider that production work and a regular product, and you'd need at least a limited license. And so I did consulting with Nathan's colleagues the last year, and I did 2 air agencies exceptional events with the smoke console for 3 years each, and that averages out to about $100. So if you were using that tool to generate like 800 maps to figure out which days, you know, what happened on which days and which days are important, it wouldn't really cost you that much.
So let me clarify. Oftentimes the money itself is a matter, but then contract gets really complicated too. So anything that we have to go through our finance team for the annual contract and things like that, that's adding the money behind it, because like you mentioned, that somebody need to work on the contract, and even if it's $100, it's not going to stop at $100. And the other example that I shared was Anaconda. That everybody knows that. Just be careful. Also, if you're using Anaconda for your commercial work, you wouldn't think that you are commercial work, but that by definition, their commercial is defined by the number of employees. So in our organization, we are commercial. So that being said, when we talked with them, it turned out at least we have to buy like 10 licenses at least minimum and something like that. So there is always a behind the scene kind of fine print that you have to deal with it. And so that's what I'm saying, that it gets more complicated than I was expecting at the beginning. And it ended up being deciding not to pursue it because we weren't sure it's going to be worth. So again, the one clarification is that I'm not looking for really free all the way. I'm not looking for it. I totally understand all the I guess the thoughts, because that was a super big deal when the Python Foundation group was struggling over like 15 years. What pathway that the language should go and everything. It turned out they come up with a totally new license agreement, which is even not similar to the BSD license either. But that's a separate story. So all I'm saying is, at least of my limited experience, it'll be good to have an opportunity to look at your product in a little piece at the beginning. Then from there, we may be able to pursue there in the next step for fully engaging the full product and things like that. Otherwise, like I mentioned, it's hard to tell whether it's going to work out for us. So just to want to clarify that I'm not really looking for the entire free data product.
So going back to HAQAST's role, I wonder if this can be an opportunity for HAQAST to help bridge that gap, because I find that, every product is different, right? These are consulting relationships and you're getting sort of a bespoke thing to fit your application. And the more HAQAST can work with private industry consulting groups as well as the end users to develop those workflows, right? That can serve as sort of a pilot validation of a product so that you can try it before you buy it, kind of thing, right? Because that's really what you want, is you want a product that suits your needs, which you may have very specific needs that cost money to develop, right? And that you can't get those for free, but in a sense of a pilot program that could be achievable. And then once you need to go into production or operational mode, then you have the confidence because you went through that pilot phase. But there is always that little element of risk, I think, that you have to take on in a pilot phase, whether you're funding it yourself or you do it through a group like HAQAST or whatever, to sort of be that proof of concept that you need, because I'm sure all of your problems are, maybe as a group you might have similar problems, but at some level they're kind of bespoke and you have to be addressed in a certain way. And as companies, as a consulting company or a data company, we don't know those problems off the bat. That's like, you have to have that two-way working relationship to develop that product. Then once it's developed, if Georgia likes it, they can go to Wyoming and say, hey, this is great, but you have to do that first step and someone has to do it. And maybe that's something HAQAST can help bridge through the different projects that HAQAST does.
And this has been a wonderful panel. Let's do another round of applause and thank our panel members.